Welcome to another episode of Shop Happenings. Today, we're going to take a look at the go-kart we're currently working on. This has been a couple years in the making. Now things are starting to come together, all the little bits and pieces. We're going to take a closer look at some individual components, some reasons why we're doing what we're doing, and just to see our progress. So let's start right with our weld joints. Some of our welds aren't quite right yet, which is fine. We're welding up, grinding off, cleaning up. The roll cage has been completely redone, refabricated. One of the seniors, who's actually doing an internship at Lockheed Martin, has spent tons and tons of time trying to come up with a geometry for the rear end. And what we've done here is he's created some bracketry to hold up our infinitely adjustable shock mounts that were built last year by a senior that's this year. They've been bolted on. We decided to bolt on and not weld on in case something goes wrong with these. We can take it off and fix it real quick. And these are engineered, so we don't have to worry about strength. So we know we're going to be good there. Our infinitely adjustable shock mount has an aluminum block that travels inside a steel case. Steel case was made with our CNC plasma cutter. We have a threaded rod that goes through that we welded a nut on the top for. We're going to weld another, or not weld a nut on the bottom. We're going to pin a nut on the bottom again so that we can dismantle this if it needs to be dismantled. We have a bushing that we made to hold it off this side, and this is what's going to allow this to be locked in place. So when we tighten up the shock, it'll pinch everything together, and this shouldn't move. At least that's the idea. Lower shock mount, similar situation, just no bushing. Bolts right now we're just kind of finger tight here, so we're going to flip this around so we have room for our brakes. We have to come up with a bracket system for our brakes yet. That's one of the things we have to work on. That may come right off our side plate here that's going to hold our motor mount, and our motor's going to sit up here at some point. We already have our sprocket in place, and we're just kind of, these are all again loose so that we can get final placements. Left side's just like the right. It's just a mirror image of our right shock mount. Same scenario. We have to put in our links yet. So I know the student that's working on this for our suspension system here. We've got 2 tabs that we've welded on. These tabs will go to links that'll be located here on the frame. One of the things he's done that's really cool, I thought, is that he added in these angled pieces for the frame to give ourselves a little clearance for the tire. Wasn't really 100% necessary, but it looks really, really cool. I like the effect, and he spent a ton of time on it, and I think it came out really nice. So it just adds a degree of kind of artistic license. If I come down here, this is where our track bar is going to be mounted on this spot right here. That track bar's got to go across and get attached to the frame. Some people call them pan-hard bars, but right now this axle is just kind of sitting here hanging out. You can't hear it on the video, but every time I turn the tire, I hear a squeak. What we did a couple years ago is we made this great big T-square. So this is a great big T-square, goes all the way through the go-kart to the other side. The reason for that is so that we can square the go-kart. So from here to the front axle, or usually we use the edge of this as long as this is parallel with our bracket. So the edge of our spindle mount, we go from here back to the T-square and we square up our front end. So now we know the front is square with this. Then we take the distance from here and we measure back to our axle and we make that match as well. So now we know that the axle here and the axle in the front are parallel. Doesn't necessarily mean the frame is square with the axles, it just means that we're parallel. To make sure we're square with the frame is we take some measurements from the edge of our T-square to the frame here, and then we go back and repeat that process back here. We make sure that's square, and then we can align the tires so that our tires line up. So now that our left and right and front and back get correct, and we can make this go-kart really true. So that's kind of the way we square up our go-kart, and then we can play with that from there to determine what's the best angles to make that work. Our seat has been mounted in. You can see we've got a couple screws down through the bottom. There's one way over there. There's one underneath the steering wheel. The steering wheel is just temporarily sitting there because we are currently working on our steering wheel mount. This will be a quick mount, so this has been machined, so this is a sliding fit. It's going to slide on. This will get welded to the shaft, and then our quick disconnect, which is on the back of the steering wheel here, will go to that. So that gets welded to there. We've also thought ahead enough to make it so we could dismantle our steering column as well. But before we get to that, our mounting plate. So there's one student that's been working on this. He's doing a great job. He drilled a hole, and then we went to the mill and made an oval out of it so that this has a little bit of clearance space. This is not going to hurt us at all because this has to flex a little bit and move because of our front suspension. So this cannot be rigidly mounted here. So this is just kind of a sliding fit. It works real good. We did this on the 14 go-kart as well. It worked real good for us. Down here we have a bushing. This bushing really simply takes a shaft and puts it to the other shaft. It's not done yet. We need to drill a couple holes here, mill a couple flat spots in each one of these. So we have some set screws here, so that this will allow our steering system to work correctly. What's unique about the system is, again, we want to make it so that we can take things apart, so that we can work on things. So this bushing will allow this steering system to be taken apart because this larger shaft is welded to our smaller shaft, which allows for a quick disconnect to work. So what this did is, this is a little longer than we wanted, but it's what we had to scrap and we just welded it on. This is actually drilled and bored into here a ways before we welded it to give extra rigidity. The reason we did this, a couple reasons. It's easier to deal with this material. We had it on hand, and it's a little bit lighter than this. There's no reason to have this any stronger than it is. So this is going to be perfect, and it actually is slightly smaller than this diameter by, I think it's like a 32nd in diameter. It's not much. So it really closely matches what comes with the rack and pinion system. Our rack and pinion's in place. Get this out of the way. Yesterday, a junior finished up his tie rod. So here's our rack and pinion. And our rack and pinion travels out to a piece of angle iron here. This is very simple. We've tried to make the radiuses, and this is really critical to eliminate bump steer. So this had to be moved as far out as we possibly could, because it has to line up with the radius of the pivot of our upper control arm. So the closer we get this and this together in a vertical plane, the easier it is for our suspension system to work, which eliminates bump steer. It keeps our tires on the ground a little longer and allows us to go the direction we want to go. Our tie rod, like I said, a junior just finished yesterday, got him bolted in. As you can see, he's got this one adjusted. We're just putting a new tire on this side, so we don't know where that goes just yet, but we'll get that squared up. Our upper and lower control arms we made here. One of my previous videos we showed we made bushings for all these. There's a little aluminum bushing in here to eliminate all our slop, and it really made it nice. So this is a very rigid system. I'm really pleased with how this is coming out on the front end. So that's kind of an overview of where we are with our go-kart. Next steps are to put on our panhard bar in the back, figure out our brakes, do our engine, get the wiring done. And there's one more thing or two more things I want to show you. One is we're going to put a wing. We had a sprint car wing donated to us. We're going to put on here. That's going to be adjustable. We've made our brackets on our CNC plasma cutter, so we have an adjustable bracket here. These were made just before break, which was last week. These will be deburred and put together. We have our little mounting hardware that we're going to put on the go-kart, and then this will allow that wing to be adjustable. So there's 2 of these, and there's 4 of these to mount that wing. So really exciting times for that. And let's go look at our upper wing. So here's the upper wing. Right now it looks like a big porcupine. As you can see, we have our cleco fasteners in place. These are our wooden stiffeners, allow the wing to be attached to this. We'll put a wood screw here and here in each one of those. So these are all clecoed together. What's really cool is if I jump around to the other side of the wing, we've started to put on one of our wing sides. I don't know exactly what the terminology is for that, but you can see looking down through here a bunch of cleco fasteners in there. So our next step after we get all of these taken care of is we've made sure that this is on correctly and it's attached to this. We're going to start removing these one by one and putting rivets in so we get this nailed down. So this is going to look really cool. This is the wing that's going to go on the top of the go-kart, and as you can see, it's coming along really nice. There's a lot of engineering here. We're hoping that this curve that we've made here out of this plane will be correct, and it'll kind of match what we did with the 14. That's kind of our hope, and the 14 wing actually works. You can kind of see, I don't know if you can see it in the video, but there's quite a curve here. And what this will do is the leading edge is out here. That's the leading edge up there. This is the trailing edge. And what will happen is the wing, this trailing edge will be higher than the leading edge, and hopefully it'll give us a little more downforce on our rear. The 14 does a little job of push in the corner, and that's why the sprint car wing, which is over here against the wall, this sprint car wing will go on the front end of that go-kart to give us a little downforce on our front axle. And hopefully between the two, we'll do a better job with our aerodynamics and sticking to the ground. So real excited about this, and I'm hoping it comes out well. I hope you enjoyed this video. Please stay tuned for more, and thanks for watching.